Hey everyone, let P equal 1, 3, 2, and 4, and let G equal E, P, P squared, and P cubed, where E is the permutation identity. So also, this is actually E equals, you could also see it as 1, 2, 3, 4 in cyclic notation. All right. We want to prove that G forms a group under the composition of functions. And then we're going to answer some of these questions based on our knowledge. So the first thing we need to do is note that we have P here, so we know the order is 4 from our previous video, because the length of P is 4. That means the order is 4. That also means we know that, therefore, P to the 4th equals our identity, which is this. All right. So we know, let's just look at P to the 5th. It's going to be P to the 4th times P, which is E times P, which is just P. We have P to the 6th equals P to the 4th, P squared, which just equals E, P squared equals P squared. So basically, let's do a Cayley table, or Cayley table, under composition of functions, and do our group here. So this is going to be E, P, P squared, and P cubed. And then write it again here, E, P, P squared, P cubed. Now remember, our order is 4 here. So basically, when you fill this in, you're going to get E, P, P squared, P cubed. And copy this down, P, P squared, and P4. So P times P is just going to be P squared. This is going to be P cubed. And P to the 4th goes here, but we know P to the 4th is E. All right, the next one, we get P cubed. P to the 4th is E. And P to the 5th is back to P. And then the last one, this is P to the 5th, which is just P. P to the 6th is P squared. And then, this is E, sorry. P to, I shouldn't have put a 4 here. This should be a 3. I was wondering why it's messing up. All right, so this is 3. So here we go. So this would be P3. Okay, so here we go again. So now we're at P to the 4th, which is E, P to the 5th, which is P, and P to the 6th, which is P squared. So we have to prove that it's a group under composition of functions. So we have no new elements in our group. So that means all elements in the table are in G, so it's closed under the operation. And that's composition. All right. Associative. Okay, all permutations are functions, and all functions are associative under composition. So therefore, permutations are associative under composition. And that's just by definition. So there's that. 3, we have to prove the identity. The identity was actually given. This is the identity, E. So basically, you could say for this, if you wanted to, E to the PI equals PI times E, which equals PI, and that's for I equals 0, 1, 2, and 3. All right, so you could say it like that. And then lastly, inverses. So for our inverses, all we have to do is look at our identities in the table. So if you look at the identities, we know that we have one here. So E inverse equals E. So that's kind of like an inverse. Here we have identity, so that means P and P cubed are inverses. Here we have an identity, so that means, because those equal E, we have P squared and P squared are inverses, because those two together, P squared equals E. P squared basically is its own inverse. And anything else? Let's see, what is this one? P cubed and P are inverses. So all you're doing is you're looking at the E's, these two from there. So here's an E. So these two are inverses. So you can write P and P cubed as well. You can switch them around. All right. And now, given that we know all this, we're going to do part B. So part B, we're going to let Q equal P squared and then solve all this. So basically, for the first one, we have Q equals P squared. So it says find the permutations Q. So that just means we just write down P twice. P squared. That's 1, 3, 2, 4. 1, 3, 2, 4. And when you do this, you're going to get 1 maps to 3. 3 maps to 2. 2 maps to 4. And 4 maps back to 1. And this should be more, let's see. Let me redo this. So basically, 1 maps to, let's do it over here. 1 maps to 3, and 3 maps to 2. So this is 1, 2. And now we're going to look at 2 maps to 4, and 4 maps back to 1. So we can close that up, because 2 maps to 4 and 4 maps back to 1. So we can close that up for the 2. And then for 3, 3 maps to 2, and 2 maps back to 2 maps to 4. Sorry, this way. So there's that. And now for P to the 159th power. So basically this is like saying P to the 4th power, which we know is E, to the 39th power times P cubed. So this whole thing, this is E to the 39th. E to the 39th is just E. So you have E P cubed, which is P cubed. So now we just do P cubed, which is this one. That's P squared times P, which is 1, 2, 3, 4, 1, 3, 2, 4. So this is P times P squared, and that's going to give you 1 maps to 3, and 3 maps to 4. 4 maps to 1. So 4 maps to 1 and 1 maps to 2. 2, let's see, maps to 1 here, and 1 maps to 3. So that's going to be this. All right. Now, in the second 2, we have Q to the 159th. So that's going to be Q equals P squared. So that's P squared to the 159th. Now we can write this as P to the 3/18th, which equals P. We want P to the 4th and 79, and then our remainder would be 2. So this part's just going to be E P squared, which is just P squared. And we already did that one, I believe, and that was 1, 2, 3, 4. And the final one is P to the 508. So that's going to be P to the 4th to the 127th, which equals E to the 127th, which equals E. And that's it. Thank you. Have a nice day. Bye-bye.